I'm going to give you a problem that you should be able to do based on your experience in physics. We're not going to do a actual statics problem because we haven't done statics yet. This is beginning of the term. So I'm going to do a problem where we have a box falling out of a truck. A truck from a height of 1.5 meters. And the question is how long I'm going to put this in duration. How long until box reaches ground? This is taking up the entire board, which is not good. All right, here we are. So a box falls out of a truck from a height of 1.5 meters. How long till the box reaches the ground? So the first step when you do one of these problems is that you should repeat the question. So when you're doing your homework, you should repeat the question. You don't have to write out all the words. You can write it maybe in more succinctly. But try to get, so this will be maybe at the top of the page. The next thing you want to do is always draw a picture. It's going to help you to understand the problem. And as you draw it, you're going to be you'll help you to start to begin to understand the problem. You can begin to think conceptually how you'll deal with it. So I'll draw a little picture here. You don't have to be an artist, but try to do it as neatly as possible. Well, this is getting to be. Okay, here's our truck, and here it is. The box is falling. Here's the box, and it's beginning to fall to the ground, and we know that the distance from this point down to the ground we said was 1.5 meters. So I'll do it. Always show the dimensions and use like an arrow. Do it like you're doing like an actual design. 1.5 meters. Make sure you show the units like that. Okay. And there are some like standard engineering design. I'm trying to look and see if it's large enough. Hopefully you'll be able to see that. So 1.5 meters, and I put like arrows on either end so we know where it starts and where it ends. Okay, so that was first step, write the problem, the question. Second step, draw the picture. And the third is where you don't just start answering doing the problem, but begin to say, based on some technique that you know, I understand that I'll solve the problem such and such way. So the initial velocity is 0. We just have a downward velocity, right? Initial velocity is 0. So you can say based on, you can say like the equation number or some concept. I'll just make up an equation number. Equation 5.33 from textbook. I know that d, the distance traveled, equals the initial velocity plus 1/2 a, the acceleration times t squared. Okay, so we write that. So you write where you got that information, you write the equation, and now you're going to write, we'll put in the numbers. We know some of these numbers. We know this is 1.5 meters. Meters equals velocity, 0 meters per second. Something's missing here. Oh, times time. And this is a really important thing. Always write the units. So you see here I wrote 1.5 m, 0 m per s, m/s, meters per second. That's how I knew immediately that the equation I wrote it was wrong, because the units don't match. But now they do. And then I'll put in here t, because t is in seconds. And then plus 1/2, and we know that the vertical gravitational acceleration is 9.81. You can put in some extra 0.67, meters per second squared times t squared. I'm sorry, I'm invading the territory here. All right, so here's our equation. We can look at the units. It makes sense because t is going to be in seconds. So seconds squared, it'll cancel. We have just meters, everywhere. So you see here, always when you're writing equations, always include the units. And sometimes I forget when I'm doing well, if you have a variable, you don't write the units, but when I'm doing problems in class, I might forget. So I always say, remind me so that I do it, because it's really, really important, because it'll help you to really understand the concepts better. So always, whenever you're writing equations, include the units. All right. The next thing is we can solve this. We know this is 0, so it's just going to be t squared equals whatever. We're going to divide both sides by this amount here. So we're going to end up with 1.5 meters divided by 1/2 times 9.8067 meters per second squared. And we can look at this and we go, meters, and then 1/2 squared, so it's second squared. Perfect, units work. And then we can say t equals, and I'll do it, well, we can do it two ways. I'll do it like this. This quantity to the 1/2 power, right? That's like taking the square root. So we'll put all that in here, 1.5 meters times 1/2, 9.8067 meters per second squared. And then we'll just come up with the answer, and the answer happens to be 0. And I'm running out of room here, unfortunately. 553 seconds. T. Okay, 5 but this is too many. No, it's 3 significant 0.553. Oh, 0. It turns out to be, if you put it in your calculator, you actually get like a couple extra zeros here. Seconds. But we're going to round this off to, like we were saying in this class, 3 significant figures. So we'll write, make sure I get this right. I got it wrong. Hold on. Here's the answer. Sorry. That's why I goofed up. 0.55300 seconds. Always, if you have a decimal and you just have like nothing over here, always put a 0 in here. That's kind of a standard practice. And then we'll round this off, and we'll write here 0.553 seconds. Okay, and that's the answer. And then when you're done with your answer, always put a box around the answer so that the person correcting it will know what the final answer is. Okay, it's really important that you're as neat as possible. Don't try. A lot of times I see people try to scrunch it into a little page, and they'll do some. If their page looks like, let me see if this is on. They'll right here, and they'll have like equations here, and then they'll do some equations over here, and then they do some kind of substitutions, and then they write it over here. You can't. Hopefully you'll see that. I don't like that. I want to see things organized. Put in like little text things here saying, here's what I'm doing in this section. And then here's what I'm doing in this section. And describe it. Okay? Do a really good job. Just like you see, go to the textbook, see how they do the homework problem, how they do the example problems. And that'll give you ideas on how to do your homework problems. Should be the same way. All right, so neatness counts. Last thing, check your answer. Take the t value here, put it back in here, and make sure that it actually, that the equation, that you solved it right, that you didn't make some kind of error. Now finally, the other thing is, almost all the problems that we're going to be assigning in homework have the answers in the back of the book. In fact, some of them even have descriptions of the sequence to actually do the problems. They're very abbreviated. So when you finish a problem, the first thing you should do, go and check the answer. Make sure you got it right. And then if you did it the first time, like working through, like following through the textbook, make sure that you can do this without any help. So it pays, believe me, it definitely pays to do it another time with the book closed and making sure you can do it under what I would call test conditions. Okay, so make sure you actually know how to do these problems, so when you actually see them on a test, you'll feel really comfortable, relaxed, and you'll just be able to do the problems and pass this class. That's the goal for everybody in the class. So that's my tips for doing the calculations and completing the homework problems. So I will see you in class.